Well, welcome back to my series of lectures. I am now dealing with relative motion in kinematics. Remember, I told you that every time I start my video, I keep telling you, you may probably share it, like it, and subscribe it because each one is linked to the previous one, right? Now, let me go back. I told you that relative motion is a ticklish subject. If you really follow it carefully and with focused attention, then there won't be any problem at all. But if you miss it anywhere, you'll be in trouble. First, I dealt with one line, buzz, person catching the buzz, etc. Then, in a plane, I tried to look at rain umbrella problems, and I gave you several cases the other day in my previous lecture. Now, I think the essence of that I have tried to put it here. I'll just give you a brief technique of getting this expression. Now, you draw VR, the velocity of rainfall, the angle with which it comes with vertical alpha, and draw Vm. Is he going on a flat surface? Is he going up the incline or down the incline, etc.? And get VRM. VRM is velocity of rain with respect to man, against which you have to hold the umbrella. This is what I told you. Now, how to get VRM? You always construct a right angle triangle with VRM as the hypotenuse. The rest, the adjacent side and the opposite side, will be a combination of these two or terms, four terms. That's all you have to do. And if you remember this, well, fine. Beta is angle of the incline. Flat surface, beta 0. Rain falls vertically down, alpha 0. So you can work on these things. You don't want incline, but still alpha is there, you can take it. All are present. Incline is present, this is present, you can take it. The negative sign is associated with positive in the denominator. This is up the incline. If you get this answer as positive, ahead you have to hold the umbrella. 0 vertically up, negative backwards, likewise. Now, down the incline, this is plus and this is minus. This is how you have. Now you try to construct it. If you still get questions, feel free to post your queries in the comments. Then I will try to address that. Okay? Now, with this, rain umbrella cases, I think I have dealt with almost to a very large extent. Okay. Now let us look at river boat problems. River boat problems. Now I generalize this. This is one side of the river bank. This is the other side of the bank. This is how the river flows. Let this be VW, velocity of water with respect to the ground. Let this person start from A. Now I am writing it here. Starts at A, wants to reach B, moves towards C, reaches D. Starts at A, wants to go to B, sails towards C, but because of this he is drifted he reaches D. This is the actual path. AD is actual path. But how? Look, when he moves, he will be pushed like this, but this is always parallel to C. Remember that, okay? Now this is it. Now the width of this river is D. Let this person go with BVW at a general angle theta. Now he is going. Why is this BC due to? BC is due to orientation of the boat. CD due to water current. So C, it should have reached in still water, but it is pushed further because of this. So this BC plus CD, here only I will write, BC plus CD is called lateral drift. BC plus CD is called lateral drift. Now we have to find out what time it reaches, and then various scenarios I am going to discuss here. Now, first of all, let this be I, let this be J. So, what is BBW? I VBW cos theta plus J VBW sin theta. What is VW? VW is always I VW. Okay? This is how it is. Now, question is time taken to cross the river. That means what is the effective velocity along AB? AB is VB sin theta. So, time taken to cross the river is D by VB sin theta. Hope there is no issue in this. T is equal to D upon VB W, of course. VBW sin theta. Okay. Now you got the time. Irrespective of anything, here there is no component of water current. Therefore, you will always get time to cross, whether it reaches B, C, D, E, F, any point. Time taken is bound to be the same. I am now taking constant speeds everywhere, remember that. Okay? Now, the lateral drift, let us call it as X. Lateral drift. How do you get X? What is the effective velocity in I? Actual VB. So, VBW cos theta plus VBW. Okay? So, I will erase this here and write VBW cos theta plus VW in this way. Suppose if I take in the total time t, then this is nothing but your x, the lateral drift. Now, too important. I hope you have written down all these points. I am now erasing this part and write your expression for t is equal to d by VBW sin theta and x is equal to VBW cos theta into, instead of t, write VBW sin theta. Okay, this is what you write. You can in fact further simplify that also. I'll do it here. This is d by VBW sin theta. Okay. Now, once you write this, you will get it as cot theta plus cosecant theta into d is equal to x. That is what I am going to write here. Cot theta plus VW by VBW cosecant theta into d, or cosec theta into d. Now this is how, so you got two expressions. So people may ask, what is the drift, what time it crosses, etc. Now let us look at special cases one by one. Okay. Now what are those special cases? First, I will find out zero drift. What will be zero drift? X must be 0. That means the boat must reach point B. We will go analytically first, then go graphically. I'll show you. X0, if you put, what are you going to get? Cot theta is equal to cosec theta. Okay? This is, cos theta by sin theta. 1 by sin theta gets cancelled. Now this is a very, very important result. Cos theta is minus VW by VBW. The moment you get such an expression, immediate conclusion must be that the angle is obtuse, because cos theta negative means angle must be more than 90 degrees. Number one. Number two, so conclusions, obtuse angle, okay? 2, this is VBW is hypotenuse. That must be more than VW, and VW is adjacent side. That is how you have to understand. If cos theta is this, what is sin theta? This is, hypotenuse. Therefore, hypotenuse square minus adjacent square by VBW is your sin theta. So, if you want to get time, you can get time. So, how do you get the time now in this case? T is equal to, that is d by under root of VBW square minus VW square. Is that clear? Directly I am substituting. Once I get what is sin theta. Okay? Now I am going to draw the diagram here. For this case, the diagram is obtuse angle means it should go like this. What should be hypotenuse? That should be hypotenuse. That is VBW. And where should he reach? He reaches B. And what is this? VW. Obviously, no, this is the angle I am talking about. At what angle should he sail? Your answer must be cos inverse or you can do, this is pi by 2 and find out this angle. Sine inverse VW by VBW. So you can write 90 plus sine inverse Is this clear to you? This is how you have to give that. Now, this is the diagram, zero drift. So it has to go like that. That means every time its orientation is, but this is going to reach B only, drift is zero. Hope the first place is clear. The time taken is this much. Okay? Now, I am erasing this part, but retaining this here. What is this? Zero drift. Okay? Now, next, I am looking at minimum drift. So this is a little ticklish because people who are familiar with the derivatives, who can directly do that. How do I do that? The first derivative with respect to theta must be zero. Therefore, cot theta is minus cosecant square theta plus VW by VBW. Cosecant is minus cosecant theta cot theta. Now this whole thing is equal to, so one cosecant theta gets cancelled. So you get cos theta is equal to, very interesting result you get. Previous case of zero drift is virtually similar, if not the same. It is minus of VW by VBW. Now in this case, obviously here, VBW must be greater than VW. Here, it is reverse. For minimum drift, VW must be greater than VBW. And what is sine theta? What is sine theta? This as we have done before. VW square remember, there is VBW here. These two will get cancelled there. Now, in this case, this is. I hope you make the small correction whenever I do such things. Sin theta is this one. And now you can write what is the time taken for this. That is d VW by VBW, VW square minus. So this is the time taken. That is the time taken. Now what is the minimum drift? What is the minimum? So I'll have to substitute it there. Whatever result I have got. I got cos theta like this, sin theta like this. What is that minimum drift? I have to simply substitute. Now you see what is cot theta? Cos by sin. So if I do, I get this minus VBW by root of VW square, that is cot theta, plus cosecant theta is also plus VW by VBW, cosecant 1 by sin theta, that is VW by root of VW square, right. It's a mere substitution. Now this becomes VW square. I am writing it here. Multiply and divide with the VBW so that value doesn't change. Denominator is same. Now you can write VW square minus VW square. whole divided by under root of all this. Okay? Now this will get VW square because both terms are same. So of course D will be there everywhere. Okay? Now what is the time taken? I'll write it here because sin theta you have written. Time taken is this. Minimum drift is D into under root of y VBW. This is the minimum drift, right? This is the time taken in the case of minimum drift, okay? Now I will give this pictorially. Now tell me what is the hypotenuse here? You have already got cos theta as minus VBW by VW. So again this is obtuse angle because cos theta negative. But VW that is here, that must be hypotenuse. That means this angle must be 90 degrees. This is VW. That is how you have to construct the. He will go like this, he will move every time, then he reaches here. This is the minimum drift. When is a minimum zero drift possible? VBW must be greater than VW. When is minimum drift possible other than zero? If it is VW is greater than VBW, you can never get zero with constant speeds I am talking about. Therefore, this minimum drift is possible with VBW being less than. So this is the concern diagram. Now we have seen first case, this is second case. What angle cos inverse minus VBW by VW. Now similarly you can write pi by 2 plus sin inverse VBW by VW. That way also you can write it. There is no problem for that. Now two cases we saw. Now we go to the third case. Third case is quickest way to cross the river. Quickest way means least time. Least time means a denominator must be maximum. Therefore, sin theta maximum is 1. Therefore, the time is d by VBW, and if sin theta is 1, cosecant theta also is 1. What about this? Cot theta, cos 90 is 0, cot 90 0. So you get only VW by, what do you get? X drift is equal to VW by VBW into D. This is the equation. I'll give you the diagram also here. Now this boat moves like this, starts like this but reaches here. So this is VBW and this is the drift. So I've given you all the three possible scenarios here. Zero drift, minimum drift, quickest time. I hope the cases are clear to you here. Now let me erase all this. And now let us look at, based on this, I look at an example. A, B, the uh, velocity is, water velocity is u, and suppose boat velocity, I'll first take a specific case u root 3. If it goes with the u root 3 relative to water, what is the time taken to complete this course? Likewise. You got this point? So it's anti-clockwise. It's A to B, B to C, C to A. Now, how to work out these problems? A, B are fixed points. So here I am supposed to get, because water velocity is u and this is u root 3. So the effective is along AB is, if the sine is d, d by u plus u root 3. Straightforward, no complication. Now look, this has come here, it has to reach C. See, unless it goes like this, it can't be drifted back to this. So first of all, we draw a parallel line here, and your u root 3 is like this, such that this is u, this is brought back. That means what? So likewise, it has come. So construction of the triangle is crucial here. U root 3, it has to, it can't be like this. If it is like this, it gets drifted away further and further. Never does it reach C. So I'm just visualizing a line, and this is drifting it back to C. Now look at this. BCD triangle. You know this is 60, therefore this angle is 120. I don't know this. Maybe I have to find out what that angle is. Why? If I want to get BC, two things. Either I should know the distance BD, so that I divide with u root 3 to get the time, or I should know BC, that is known to you, but I don't know the velocity along BC. Therefore, I have to get velocity along BC. That is very crucial for you. Now try to get, there is a velocity here, let this velocity be V. Now generally make use of sine formula to get these answers. Now what is that sine formula? U by sine theta. This is u root 3 by sine 120, and what is this? V by, say, sine alpha. Now I don't know V, I don't know alpha, but I have to get one and get the other automatically. But if I make use of these things, how do I get it? U gets cancelled, alright. Sine 120 is 90 plus 30 cos 30 root 3 by 2. So 1 by sine theta is equal to sine theta sine theta cos 30. There is a root 3 there, isn't it? So how do you write? It becomes 2. Therefore, sine theta is equal to 1 by 2, or theta is equal to 30 degrees. Now straightforward, with theta 30, this is 120, what is alpha? 30 plus 120, 150, therefore it should be also 30 because total angle must be 180. So alpha is also equal to 30 degrees. So u by sine 30 is equal to v by sine 30 or v is equal to u. See, so this is nothing but u. Therefore, time from B to C is d by u. Now this is similar to this. Why? It has to reach A. So how should it go? It should go so that it reaches. Same analogy you can apply and then write it down as A. What is the total time means? What do you do? D by u plus d by u plus d by u into 1 plus root 3. Now d by u is common. Now I will write it here. D by u is common. Then you have 2 plus 1 by 1 plus. Now you can simplify and write. You try, if it goes clockwise, what time it takes. That is what I would expect you to do it. I hope this problem is clear. Okay. Now, okay. Now you saw river boat cases, some 2-3 cases. Now, for example, I look at some general cases, miscellaneous cases. A few examples I'll give you, and then I will wind up this relative motion. Okay? Now, in most of the cases, see, you remember, we tried to say a person is here, another person is here. Now, these two will meet at some point, let us say. Okay? Supposing this is how he is going, and this is how he is going. Now, from this, his initial distance is r naught, or I will write it as RAB to start with. We have already seen 2 people, 3 people moving, how they will meet at a point, number of people, etc. That is highly simplified case. I am now generalizing it. First important thing, we will try to get the trajectory of one motion with respect to the other. So B with respect to A, whatever, right? Or A with respect to B, whichever you want. Okay? Now suppose this is VA and this is VB. Alright. Now what is velocity of V with respect to A? What is velocity of V with respect to A? So first of all, to get that is VA. Velocity of V with respect to V minus VA. Okay? How do you get that? VB minus VA. So it's like this. So I am taking it here. VB, velocity of V with respect to A. Now this is little VBA, let me take it as VR, okay, relative velocity. Now, as you know, you said they meet at one particular point, say D. They follow certain path and then maybe likewise they may come and reach. What is happening, we will see now. See, this velocity VR has a component, along the radius or opposite to the position vector. You get this point? This has got a component opposite. That means this is tangential to this line, And because of this, the distance is getting reduced. So, if I call this VT tangent, then if the distance reduces, therefore negative sign, then in small time dt minus dr vt, that means what? Every t time this is getting reduced and finally becoming 0. So the component along the position vector reduces the distance, and the component perpendicular to the radius, that position vector, turns the body path. Okay, that could be either like this or like this, whichever way. Okay, so what does this particular component do? Perpendicular component will not contribute to the distance changing. Tangential component will not contribute to curvature. So the tangential component is responsible for reducing the distance. And now, if I take, say this is your position, after some time this is your position. Now, this is dr, okay? If this angle is d theta, you know, by simple geometry, this angle is r d theta, and this arc length becomes r d theta. This arc length is due to which perpendicular, I will call this as VP. VP stands for perpendicular component. So, R d theta is equal to VP into dt. I hope you have understood this point. When you have a relative velocity, because of which you say they are meeting, they are not only meeting, the path is also decided. Because the relative velocity of B with respect to A means I am taking A to be constant and B alone is moving. To us it appears as though they are moving along straight lines, but no, they are moving along this. Therefore, I got two expressions, perpendicular and parallel, right? If I do that, what do I get? Minus dr by r. You know, these are all constant speeds. Therefore, you can directly integrate these two. Of course, you have to have an idea of integration. That's how I am proceeding. What is the initial distance? What is any general distance? That could be 0 also eventually. But what is the general distance? R. Therefore, ln R. You know, every time you take integral dx by x, you should write ln x, not log x. Log x with respect to base 10, with respect to that exponential e, with respect to e is called natural log. So, every time you do an integration, you get only this, and this is, if these two are constant, then integral d theta becomes theta, right? So, you can now ln r by r naught is r by r naught is r. Finally, r is equal to r naught e raised to minus vt theta by vp. This is the path of one body with respect to other when they are trying to meet. Remember? Now, if r has to be 0, this has to be infinity. Theta must be infinity, then only they will meet. So, for them to meet, theta must be infinity. is how you should understand. This is the trajectory in all such cases. Hope this is clear to you. Okay? Now, I'll tell you another problem. Person starts at A, he wants to reach B. Peculiarly, this person always directs and moves towards B only, always. So that means as he starts, pushes him with you. Let me presume that he also moves with you. Also. So, at one stage, this is how, let us say this is theta. This is the, initially it is R naught, the distance. Now whatever is the distance, it is here. Okay? Now what is this U? Okay? Now this U, if I take a component of this, you know that this is theta, therefore this is theta, this is 90 minus theta, U cos 90 minus theta, U sin theta, perpendicular to this R, this is U cos theta. What is the velocity of approach towards B? U minus U sin theta. I mean the same as what we have kept. In small time dt, the distance is reduced by dr is equal to minus dr. Now, as before, U cos theta is perpendicular component. Therefore, R d theta is equal to U cos theta into d, because there is no other component there. Same case as we did before. Now, I am dividing. So, what am I getting? U also gets cancelled. 1 minus sin theta is d theta is equal to minus dr by r. This one by cos theta sec theta d theta minus tan theta d theta sec theta, both you have, that is equal to minus ln r. Now limits starting with r naught to any final distance r. These are all 0 to any theta, because theta 0. Suppose if it reaches the other bank means theta is equal to pi by 2. If it reaches the other bank, I am not taking that case, I am generalizing it. Okay? Now I am erasing this part. So what do you get? Sec theta d theta is zero to theta minus tan theta is ln sec theta. Again 0 to theta. And on this side you have ln r by r naught with a negative sign. Okay? Now I am erasing all this. So what are you getting? Theta 0 means this is 0, this is 1. So by 1 ln sec theta plus tan theta, this is, if I negative sign, if I remove this becomes negative, and this becomes ln sec theta, and this is equal to ln r by r naught, or ln sec theta by sec theta plus tan theta. You know, in south it is called secant theta, in north it is called sec theta, but it is saying I taught at both the places, therefore I use both of them common. Sec theta by sec theta plus tan theta. Look. After traveling theta, suppose if you say 60 degrees, what is the distance from point B? He may ask, substitute that value here. Now if I say I want that this to reach the other bank, I told you theta must be pi by 2. So sec pi by 2, secant pi by 2, cos 90. Now you can see you can't get that. Therefore, divide that. Sec theta means 1. Tan by sec is sin theta. So theta 91, 1 by 2 or r naught by 2. What do you mean by that? If it always moves like this is exactly r naught means r naught by 2. That is how you have to understand this particular case. Hope this is clear. These are all some special problems that I am discussing. Right. Hope you have taken note of it.